All right, Kyle. All right, guys. Well, we are in week 7 of our quantitative methods class. We're in our second week of working with SPSS, and so this is So here's a follow-up assignment that we are going to be discussing outliers, normality, and correlations. Kyle, I think just a moment ago you had said you don't have any specific questions, but one of the other students in class had emailed some questions that she had specific to number 10, 11, and 12. So maybe we can kind of walk through her questions and see where that leads us. And if you have other questions that come up, then feel free to, jump in. How's that sound?
Sounds good.
All right.
Sounds good.
So starting with number 10 is asking us about z-scores. So it says using a z-score of plus or minus 3, how many outliers are there in the final exams for each of the course sections? Wants us to create a table to list the raw data and the corresponding z-score for any potential outliers. But essentially what we're going to try to do, and one of the things that we need to do in order to answer this question, well, it's asking us to determine if there are any outliers. And the question is defining an outlier by greater than plus or minus 3 standard deviations. We need access to the data file. When you open the data file, you're likely only going to have these 3 variables: final exam, GPA, and class section. So we need to be able to see how we actually can convert final exam scores to a z-score. And just so that we conceptually understand what that's doing is, when we convert to a z-score, we're just standardizing that score. We're just saying for any data point, how far below in a standardized score is it above or below the mean. So it's going to take every single one of these exam scores and turn them into a standardized score. So what do? Well, we go to Analyze, Descriptive Statistics, Descriptives, and then we're going to choose our variable that we want to select. So in this case, we want our final exam scores to be converted. And then this box right here that says save standardized values as variables. We're going to check that box. And when we check that box and then click OK, so it's going to give us all these descriptive statistics, but it's also going to standardize those scores. So it'll pull up our output. It'll give us all of our standard deviation for the entire group. But then it's also going to, back over here, give us the z-scores. Now, those are z-scores based on the entire group. So not just based on class section. So here it grouped all of them together. So what I've asked you to do is to be able to convert for each class, convert these to a z-score, and then determine if any of those are outside of plus or minus 3 standard deviations. Obviously, what we can see here in converting this to a z-score is that when all of this data is combined, that no, this is not greater than 3 standard deviations. But we need to see about creating a way where we can just, for each class section, convert those to z-scores. We'd have to do a little bit more digging here with our frequencies in order to be able to do that. Sorry, not our frequencies, under our descriptives, to be able to see how we can do that for final exam score based on section of kinesiology. And so the way we have our data set up here, that we cannot easily do that just yet. we'd have to do some configuring with our data. We might have to create another column of section 1 and another section of section 2. So for example, maybe we create a column of, so that would just be class 1, if that'll copy and paste. And then if we took another column, so then we could easily convert by class. We could then go in, if we, well, we're going to have to change this variable. So we call this maybe section, we call this section 1, and then call this section 2. Well, then we could go into our data view, and then we can easily go back and go to analyze to our descriptives, and we could then, for section 1, for section 1 and section 2, and we can save those as standardized variables. Now, when we go back, we see here we've got z-scores for just section 1, and we've got z-scores for just section 2. In that case, our score of 46, when it's separated out by class section, we see that our data value 12, that exam score of 46, is that greater than 3 standard deviations away from the mean? It is. It's over -3 standard deviations away from the mean. So that's kind of what question number 10 is asking you to do. It wants to know are there any data points greater than or less than 3 standard deviations away from the mean? So we need to convert each class section to z-scores. Does that make sense? Or did I royally confuse you?
Nope, we're good on this end.
I mean, using our box plot, any of the outliers are going to, I mean, it's going to show us outside of our interquartile range, and any that are outside of, that are considered outliers. In this case, our data point 12 is considered an outlier. So we could go back and we could look at that exam score, and it's saying that data point 12, or in this case 46, would be a score that would be considered an outlier. So that would certainly be one way to do it. Another way that we could take a look at it is what we would need to do if we were going to sort of do this by hand. We would need to be able to calculate our interquartile range, which we know that interquartile range is just the difference between the 25th percentile and the 75th percentile. And that's exactly what let's go back here to our output. That's what these values are. So here, this would be our 75th percentile and our 25th percentile. And so SPSS can easily give that to us. But if we can calculate what the 25th and the 75th are, well, the difference between those is what we're going to call our interquartile range. And oftentimes then what we do to determine, outliers would be 1.5 times the interquartile range. So I can tell you right now, I've already calculated this out. This value here for class 1, this value corresponds with 89.5. And then this value here corresponds with 76. So 89.5 minus 76 is 13.5. And then we take 1.5 times that interquartile range. So 1.5 times 13.5 comes out to be 20.5. And that's where you get these whiskers out here. So 89.5 plus 20.5 comes out to be 110. That's what this value should represent right here. And this value down here should represent 55.5. Now, for some reason, that's not showing, that's not matching up here with what this is showing on our graph here. I'd have to double check and see exactly why in calculating that out by hand, why that's different. But anything that's outside of 1.5 times the interquartile range is to be considered an outlier. And that's what this data value here is, this data value 12. And that corresponds with the exam score of 46, which is a pretty low exam score. Okay, all right. Well, yeah, so we just showed a couple of ways to be able to determine if something is an outlier. First, by the z-score method, greater than or less than 3 standard deviations away from the mean. And then the second way that we just did that is we used the box plots, and we look at 1.5 times the interquartile range. So 1.5 times the interquartile range above and below, we see that there is one outlier. We see in section 2, using box plots, that there are no outliers.
I'm sure this might be addressed in the book, but is the plus or minus 3 z-scores a pretty standard outlier determination?
I'd probably say using the 1.5 times interquartile range is more common. But if our data were just perfectly normally distributed along our normal distribution, we know that above 3 standard deviations should capture about 99.7% of our data.
Okay.
Plus or minus 2 standard deviations should capture about 95.5%. And plus or minus 1 should capture about 68% of our data. So if something is greater than 3 standard deviations, I mean, you're talking about very, very small probability that it's within, 99.7% of our data. It's a pretty extreme score if it's greater than 3 standard deviations on a normal distribution.
Right.
So I just wanted you to see how those compare with one another.
Okay, yes, got it.
But to answer your question very specifically, interquartile range, 1.5 times interquartile range is probably more common. All right, so let's look at, so that kind of starts getting us working towards question number 10. The next one is the next two actually are asking about correlation. So just a few concepts about correlation. We know that correlation always ranges from anywhere from -1 to +1. And that if something is perfectly correlated, meaning +1 or -1, it means that there's a direct correlation there. Very rarely in life are 2 variables perfectly correlated with one another. So the closer to the extremes of +1 and -1, the more strongly correlated 2 variables are. As we come towards 0, meaning that 2 variables are not correlated, there's very little relationship between the 2. We would say that there's probably some sort of a correlation, for example, between height and weight. For example, the taller somebody is, generally they probably weigh a little bit more. Somebody that's 6'7" is generally going to weigh more than somebody that weighs a little bit more than somebody that is 3'7". But that's not always the case for height. Somebody that's 6'7" could weigh less than somebody that's 5'7" in theory. So here we're just talking about the relationship between 2 variables. And that's what this question is asking. It wants us to determine that relationship between 2 variables. So final exam score and GPA. So we need to be able to correlate those 2. And then number 12 wants us to ask for the coefficient of determination for final exam score and GPA when both sections are combined. So some of the other questions have been asking us to separate the classes out. Now this one is asking us for 11 and 12, just combine all the data. combine all the data for class section, so we don't have to worry about section 1 and section 2. We're just working with one data set there. So let's look here at our kinesiology class. So to do that, we're going to go to Analyze, Correlate, and we call this a bivariate correlation, meaning we have two variables. And so what were the variables, Kyle, that it was asking us to look at?
The final exam score and GPA.
And GPA, there you go. We're going to call this a Pearson. That's a very common correlation. We don't necessarily need it to give us our means and standard deviations. If we wanted it to, if we wanted SPSS to report those, we certainly could. We're just asking for it to run the correlation. Let's see here. All right, so this is our correlation matrix. What we see here is that final exam score is being correlated with GPA, and then you'll see as well that GPA is being correlated with final exam score. So it just replicates the table. Really, we just need 1/2 of this table. All right, so we have final exam score, the Pearson correlation. Obviously, the correlation between final exam score and final exam score, its own variable, is going to be a perfect correlation. But between final exam score and GPA, this is saying that there is a 0.928 correlation. And then SPSS will tell us, is that significant? Is that a significant correlation? Or is that a strong correlation? And yes, it is. It's significant at the 0.01 level. So that's saying that there is a particularly strong positive correlation. So if we were to say that there's a positive correlation between final exam scores and GPA, that's suggesting that the higher somebody scores on final exam score, they tend to score high. They tend to have a higher GPA. Make sense?
Mm-hmm.
So that should get us, I mean, that's how you run a bivariate correlation in SPSS. Now, question number 12, what's the question asking us? It wants us to find a coefficient of determination. So we need to understand what a coefficient of determination is. And essentially, Kyle and others that are going back and watching this video, it's saying that when we have a correlation, even though this is a strong correlation, well, how much of the variance between final exam score, well, really, how much of the variance in GPA is being accounted for by final exam scores? So in order to be able to calculate that, it's just the square. Okay, so we're going to take 0.928 squared. So 0.928 times 0.928, and that whatever value that gives you, that's the coefficient of determination. And so that's going to say how much of the variance in final GPA is accounted for by this particular variable. Let's just say that gives us, we're not going to give the answer right here, but let's just say that that comes out and that gives us a value of 0.3. All right. Well, that's saying that about 30%, and how you would interpret that, about 30% of the variance in GPA is accounted for by this one variable, final exam scores. And that's how you would interpret a coefficient of determination. And so that question number 12 is asking you then to calculate the coefficient of determination and interpret it. And that's how you would do it. Mm-hmm. Any questions on correlations?
No, it's a lot more prepared for that than I thought it was.
That's pretty much a review for you on that one, on those two?
Yeah.
All right. Yep. Yeah, nothing too overly complicated about those. Honestly, Kyle, for these first couple of weeks, and those of you that are, going back and watching this, Um, we're just trying to really see in the first couple of weeks, can we run some very basic analyses? Can we get caught up to speed on SPSS? Can we get it loaded on the computers? Can we import a data file? Can we run some very basic correlations? Here very, very quickly in the next couple of weeks, we're going to start getting into some inferential statistics and some more in-depth calculations. So those of you that have had some experience with SPSS, I would think that the last week and this week probably haven't been all that complicated of analyses, but for others that haven't had an SPSS course or any kind of a stats course, then you got a little bit of time to sort of get caught up here. So with that being said, that's kind of an overview of how we're going to run some analyses and determining outliers and doing some basic analyses on correlations. So Kyle, do you have any other questions for this week's homework? Anything that you ran across that you still have questions about?
No, I don't think so.
Okay. Well, that
could I maybe share my screen with you real quick and see if we can see where I'm missing the if I'm overlooking the data set?
Yeah. Go ahead and share your screen. Go for it.
Yeah, so just this is what I'm seeing. I don't know if I'm saving the assignment the wrong way, but this is what I'm seeing, and I wasn't able. I manually inputted. Am I on what?
Are you able to go back to week 6?
Yes.
Is that assignment, or is that assignment closed?
I'm able to get back to it.
All right, so the data file isn't there. I'd have to double check. It might have been one on one of the previous weeks. Scroll up, keep going up towards the top. Yeah, you don't have access to files there on your left-hand column. I will repost the data file. It'll be an SPSS.sav file, and so go to week 7. I'll post that just under the PDF file. How's that? I'll go in and do this right after this tutoring session.
Sounds good. I did the whole assignment last week and realized I'd left out one data point.
Oh, well.
So I combed back. It was getting down, so I just combed back through the entire set.
I got
you.
And
I'll put it back in. And
okay.
I actually took all the stuff to break them down into 2 sections. I shifted over to Excel to get to calculate the quartiles.
Okay. Well, yeah, all of these data files that we're going to be working with from this point forward in the semester, you should have access to. Off the top of my head, I'm forgetting which week that was. But I'll go back into week 7 and repost that for you.
Okay. Thank you.
Yes. All right. Well, if that's, if there were no other questions, then we'll kind of push the pause button there. Guys, email me if you have other questions, about this week or previous weeks, but hopefully, we're staying up to speed. So in looking forward, we've got 1 more week next week, and then you will have 2 weeks to actually complete your midterm. So we'll do we'll continue forward next week. And then after that, then have 2 weeks to finish up the midterm before we start on with new content the second half of the semester. That's the plan.
Great.
All right, man. Great. Well, good deal. All right. Well, then, let's, I'm going to go ahead and finish this up and get that posted, get that data file back on there.
Thank you.
All right. Thanks, Kyle. We'll see you later.
Yeah.